Hello viewers, welcome to video number 110 of the channel MALACHEMPHILIC, and this is the 50th episode of Chemical Thermodynamics. Topic of this episode is Criteria of Spontaneity, second part, that is part 2. Now let's start. In my earlier videos, in videos number 106, 107, 109, I was discussing about this criteria of spontaneity and prediction of spontaneity, and this video is just a continuation of that. Now, in video number 106, I explained that the spontaneous process or spontaneous reaction or the criteria of spontaneity or the spontaneity can be predicted from the entropy change. How? We know that entropy change of the system plus entropy change of the surroundings greater than 0 or positive for spontaneous process or spontaneous reaction. Okay, and this total entropy change, that is entropy change of the system plus surrounding, we call it as entropy change of the universe. And this entropy change of the universe is equal to 0 when the system is in equilibrium. That means at equilibrium condition. Now, if this total entropy change, that means entropy change of system plus surrounding or delta S universe is less than 0, that is negative, then it is non-spontaneous. So this one already I have discussed. You can refer my video number 106. Now the problem is, with the help of entropy change, we can predict the spontaneity, but in that case, we have to determine the entropy change of the system as well as surroundings. And mostly it is very difficult to determine the entropy change of the surroundings. Then what we need? We need the system-based parameter or system-based function which depends only on the system to predict the spontaneity of the process. And already I told in that video that these two functions are, one is A, that is Helmholtz free energy function, which is equal to E. E means internal energy minus T temperature, S entropy. So this A is known as work function or Helmholtz free energy function. Okay, and from the change of A, that is delta A, which must be equal to delta E minus T delta S, we can predict the spontaneity or we can determine the spontaneity of the process, right? But this will happen under the condition of at constant, this one is feasible only at constant volume and temperature. But most of the reaction and process we perform at constant pressure, that means constant atmospheric pressure. Okay. Now another function, that is Gibbs free energy function, which is equal to H minus Ts. This G is, this is Gibbs free energy function or Gibbs free energy. Okay. So from the change of this Gibbs free energy also we can predict the spontaneity. That means delta G is equal to delta H minus T delta S, and here it is at the condition of, or under the condition of, at constant pressure and temperature. So both this Helmholtz free energy function and Gibbs free energy function, these are only system based function where you need not determine the change of the surroundings, change of this function for the surroundings, system based function. But this Gibbs free energy function is more important or most important in predicting the spontaneity, because here it is under constant pressure and temperature, and most of the process or most of the reaction in the laboratory we perform at constant atmospheric pressure. Okay, so this is more important. And already we have discussed that when this Gibbs free energy function delta G for any process or any reaction is less than 0 or negative, that indicates spontaneous process or reaction. Okay, and when delta G, Gibbs free energy change of the process or reaction, is 0, that indicates that it is equilibrium is reached, at equilibrium. And when this delta G, Gibbs free energy change, greater than 0 or positive, that is non-spontaneous, that means that indicates non-spontaneous process, spontaneous. Okay, so all these things we know. Now let's see under what situations this delta G or Gibbs free energy change is negative. So number 1. So delta G, that is equal to delta H minus T delta S. Now we'll see the first condition. Say when delta H, that is positive, and delta S also positive, then what will be happen to delta G? Delta G will be, this is positive, okay, minus of, this is positive, so T delta S is positive, then this is positive, this part positive, negative, negative. So overall it will be negative when, so it will be negative when this T delta S greater than delta H. So this part will be negative when this part will be bigger. That means T delta S greater than delta H. That means at high temperature, this process or reaction will be spontaneous. Okay. Now we'll see the second situation. What is that? Say we know this delta G is equal to delta H minus T delta S. Now the situation is when delta H is positive but delta S is negative. Now let's see. So delta G will be, this is positive, so this is positive, minus of this T delta S, this is negative, because delta S is negative, so it is negative, 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 positive, so overall it is positive. That means under this situation it is always non-spontaneous. Always non-spontaneous. Under this situation means when delta H is positive, endothermic, and delta S is negative. Now we'll see the next one. See the third one. Delta G is equal to delta H minus T delta S. Now the situation is when delta H is negative and delta S is positive. Now let's see. So delta G will be, delta H is negative minus T delta S will be positive because delta S is positive. So this is positive, negative, negative. So it is always negative. So under this situation, delta H is negative, exothermic, delta S is positive. This is always spontaneous. Now the fourth condition. So once again you will write delta G is equal to delta H minus T delta S. Now the condition is when delta H is negative and delta S also negative. Now let's see. So delta G will be delta H negative, so negative minus T delta S. Delta S negative means this is also negative. That means this negative will be positive. So overall it will be negative. So this will be negative when this is positive, this is negative. So overall it will be negative when delta H will be greater than T delta S. Okay. Delta H greater than T delta S means T delta S less than delta H. That means at low temperature it is spontaneous. Okay. In the conversion of limestone to lime, that is calcium carbonate converted to calcium oxide and carbon dioxide, delta H0, that means standard enthalpy change. Standard enthalpy change means molar enthalpy change under standard condition, that is 1 atmosphere pressure, and generally will take 25 degrees centigrade, that is 298 Kelvin. So standard enthalpy change is 179.1 kilojoules and standard entropy change, here also molar entropy change under standard condition, that is 160.2 joules per Kelvin at 298 Kelvin temperature and 1 bar. This is the standard condition. Assuming delta H0 and delta S0 do not change with temperature, the temperature above which the conversion will be spontaneous, these are the options. Now let's see. Conversion spontaneous means this question came in All India Engineering Entrance Examination in the year 2007. Spontaneous means delta G must be negative, right? Delta G is equal to delta H minus T delta S. Here it is standard condition. So delta G naught is equal to delta H0 minus T delta S0. Okay. So this part should be negative. That means delta H0 minus T delta S0 should be less than 0. Then only it will be spontaneous. Right? Okay. Now, so here what we can write? That delta H0 less than T delta S0. Okay. Or what you can write? T delta S0 greater than delta H0. So from here we can write that T must be greater than delta H0 by delta S0. Okay. So, delta H0 is how much? They have given 179.1. So, T must be greater than 179.1 kilojoule, and this is in joules. So, we'll take it into kilojoules. So, you have to divide by 1000. That means it will be is equal to 0.1602. Okay. And if you calculate it, it will come, this part will come, this is equal to your 1117.9. Okay. So, T must be, temperature must be greater than 1117.9. That means 1118 Kelvin. Okay. 1118, that means answer is C. So, this temperature, above this temperature, it is spontaneous. T must be greater than this temperature. Okay. Now, let's see another question. For the reaction X gives rise to the product Y plus Z is exothermic. State the conditions at which the forward reaction is favored. Just now we have taught. So, exothermic, that means delta H, that is negative. Okay. Achha, forward reaction is favored. That means delta G, which is equal to delta H minus T delta S, must be less than 0. Right. Now, so exothermic means it is already negative. Right. So, this is delta H is negative. So, this part is negative. Now, if delta S is positive, then positive, negative, negative, then also it will be spontaneous under any temperature. Right. So, this is negative. If, or we write when delta S is positive, then what will happen? Delta H minus T delta S, that means it is negative, minus of this is positive. So, overall it is negative. So, at any temperature. So, when delta S is positive, it is spontaneous or forward reaction is favored at any temperature. That means at any temperature, the reaction is spontaneous. Reaction is spontaneous, provided they have only told that delta H is negative, exothermic, provided our delta S should be positive. Now, if or when delta S is negative, then what will happen? Delta H minus T delta S. Delta H is negative minus of T delta S. Delta S is negative. That means overall this will be negative. So, this part will be negative, negative, positive. So, if overall it is negative means this part should be, this part is positive. Overall it is negative means this part should be less. That means this T delta S, so T delta S, this overall positive part, it must be less than delta H. Okay. So, this must be less means that forward reaction is favored at low temperature. So, at low temperature, it will be favored when delta S is negative. If delta S is positive, then no effect of temperature. So, hope you have understood. Thank you.